This is the Check Your Understanding for 7.3, Sampling Distributions of Sample Means. The length of human pregnancies from conception to birth varies according to a distribution that is approximately normal, with a mean of 266 days and a standard deviation of 16 days. Find the probability that a randomly chosen pregnant woman has a pregnancy that lasts for more than 270 days. So you want to think about your observation. Is it just a value? Is it an X bar? Is it a p hat? And notice how it says find the probability that a randomly chosen. So you're just choosing one woman from the population. So it's not like you're taking a sample and seeing like a sample mean. So this isn't an X bar. It's just a value. So this is actually a chapter 2 problem where you have a normal distribution with a mean of 266, a standard deviation of 16. Make sure you label that with mu and sigma. So it's not mu sub X bar or sigma sub X bar, it's just mu and sigma. That's why that distinguishing it is so important. You can find the z-score. So it's 0.25, standard deviations above the mean, and you can find the area with table A of how much is above that value. Or use your calculator from 270 to infinity with this mean and that standard deviation. But your probability is 40.13%. So a chapter 2 problem, but recognizing that is now difficult. But now let's look at the wording of number 2. Suppose we chose a simple random sample of 6 pregnant women. Let X bar equal the mean pregnancy length for the sample. What is the mean of the sampling distribution of X bar? So we learned how that's just the same as the mean of the population, which is 266. So that's the mean length. So even if we take samples of size 6 or size 10 and we take the average of all those averages, it's still going to be 266. What's going to be different, though, is the standard deviation. The sampling distribution is going to have less variability. Now, it passes the 10% condition because 6 is less than 10% of all pregnant women, sufficiently small. We don't know how big the population is, but it must be large enough. And you calculate it by doing the population standard deviation. That's sigma divided by the square root of n. So 16, that's the population standard deviation divided by the square root of your sample size. You get 6.532 days. So if we take many samples of this size 6, we expect the sample mean to typically vary by 6.532 days from the mean of 266 days. So that interpretation is important. So now we can use that information to answer number 4. Find the probability that the mean pregnancy length for the women in the sample of 6 exceeds 270. So this 270, you're thinking about an X bar, a sample mean being 270 or greater. So when you draw your normal curve, now the mean is the mean of X bars, which is the same as the mean of the population, but your standard deviation is that population standard deviation divided by the square root of n, which is at 6.532. So that'd be 27.03%. So it's really important to distinguish the difference between what we had in number 1 and what we have here. Both of these pictures look pretty similar, except the standard deviation is different. Because in number 1, it was just a single randomly chosen pregnant woman, just one from the population. And this is the distribution of the population. This is a population distribution that's drawn here. Whereas in number 4, this is a sampling distribution. If I were to make a big pile of X bars, take lots and lots of samples of size 6 and find the mean pregnancy length for all those samples and make a distribution, pile them up, and then that's what we're looking at here. The probability that in that sample of 6 that sample mean would be 270 or more, 27.03%.